Welcome back everyone to our next Webfest workshop. This workshop will be about cybersecurity. You're all working on web applications, and security is a very important aspect. So this is why we have this workshop, which hopefully you will learn a lot. I don't doubt it, because we have a really high-profile presenter. We have Stefan Lueders with us, head of CERN Computer Security. And he will give you a workshop on how to be cyber secure. Now, for all our people here on this call, please stay muted. And if you have questions, please post those questions after Stefan's presentation. And without any further delay, I'll bring you Stefan. Stefan, thank you very much for being here.
Thank you very much. I hope you can see my slides as of this very moment. There we go. So thank you very much for having me here. Good afternoon. It's 12:03. So I would like to spend the next 30 minutes not really about a presentation, but more about a plea to you watching and listening to me, because it is you who is using lots and lots of different programming tools. We discussed a little bit before about hardware. Somebody mentioned Raspberry Pis, Arduinos, and all the stuff in your projects. And I'm the guy with my team who in one moment or the other have to secure all those different devices. So this is why I'm happy being here. I would like to make a plea to you, a plea to when you do your project, when you do development, when you do testing, to use a couple of tools, go for a little bit of training to have your installations, your project, your hardware, your software more secure than what you would just deliver if it's rushed out in a very, very fast time. So the problem in cybersecurity is not a technical problem itself. The problem is me, definitely, I know, but unfortunately also the problem is you, which makes us the problem together, because when you're programming, you might not necessarily look at the fact that you program it in a secure fashion, which means that later on I have to take care on that one, and I'm a lazy guy, so I'd like you to do the work for me. So on the left-hand side on the slide, you can see an example why cybersecurity might be interesting and definitely important. CERN is running a couple of interactive Linux clusters with hundreds of different servers attached, and for one of the maintenance tools on the servers, we were running since 2004 cron job as root, which is more or less the master on the computing cluster. You can see the code here, starting with for each and a small little loop. Fine, this code is doing its work, but if you look a bit closer, you'll figure out that you can, as just a user on this interactive cluster, and there are thousands of users in the interactive cluster, they get hold of this function, which they can become root themselves, because this single line here, head -$100F piped into $NF, is user controlled. So you control this, which means that you can put into $F any shell command, and you can pipe it into a symbolic link of a system file, and this gives you root privileges. So why is that? Because somebody was hacking this code in good faith together, without really thinking about security and the implications. And this is just maybe a little more complex example, but we will come back to this again and again during this presentation, because what is the most important thing for me, and if there's just one message you should take home, is filter the input if the input is coming from unknown third-party sources. So let's have a look at the problem a little more. Look about cybersecurity. Talking for CERN, CERN is target. There are people outside who are looking what CERN is doing, which services we're running, what we publish on the internet, which web servers we're having. They're looking for our interactive clusters, maybe even databases exposed to the internet. They're scanning us on a permanent basis, even at this very moment. So here's an example of Siri Tritsi, who found on the internet using Google some passwords, source codes, and tickets, which are exposing information about CERN. Not pleasant. Fortunately, here the passwords were just dummy passwords. I come back to this one. There are guys who are a little more aggressive than the first guy. Here's an email which we received a while ago saying I didn't get access to a database, but hacked the website and would like to know whether you're the right person to talk about this and try to make a deal. And principally what the guy is trying to tell me is, I found a vulnerability on your website. If you want to have it fixed and I tell you what it is, pay me money. So he's blackmailing us. And of course, this is not really appreciated. Could be worse. He can misuse what he found and try to break into CERN. Unfortunately, in this very case, we managed to get in contact with the guy and ask him more details. And while he was looking for more details, we spotted him in our intrusion detection system. So no money lost, and we fixed the apparently very, very small problem in the end. There are videos on the internet you can find. Hacking the Large Hadron Collider with a so-called cross-site scripting vulnerability. I will come back to this in a second. Hacking the Large Hadron Collider with an authorization bypass. Those are videos some more aggressive attackers are posting to show how they managed to get into CERN and apparently the LHC, but they didn't manage to get anything closer. And I will show you the corresponding videos or the remake of the videos later. And then there are people who are sharing on Pastebin and somewhere else on the internet using an exploit. And exploit is some software to really crack a system. Using the exploit on CERN would be a win, hacking the people who created the internet. So there are people targeting us. They are really interested in us to break into CERN for different reasons. So the simple reason is just because they're security researchers and they love us, so they would like to give us some help, and they show what they find. There are others who would like to boast how well they've done breaking into CERN, or maybe even misusing their power. Of course, they're the cyber criminals. CERN is like any other organization, so they're attacking any other organization, and maybe they can extract some money from CERN or misuse our computing clusters for cryptocurrency mining. And then we go up the level to espionage and sabotage, and even nation states which try to break into CERN. So we get the whole portfolio which is attacking CERN. So here's what I said before: cross-site scripting. Just a very small example of a very old web page, the CERN phone book. If you look in this input field in the middle, starting with script, usually you just put your name there or telephone number, and you get the owner of the telephone. So that's fine. But here, you managed to put some JavaScript in. JavaScript script alert. This is prone to cross-site scripting. End of script. You can even put it at the very top at the URL bar if you want to. And this web page was not filtering the input. It wasn't controlling the input. It accepted the smaller sign, bigger sign, the brackets, the hyphens, and everything else. So it was executing more or less what's happening here, and it's just popping up a small alert window. That's the command alert with some text inside, which is the parameter. Not bad here, but in principle, if you can now push any other JavaScript, this can pose a problem to the organization. This is called cross-site scripting, and it's only possible because the creator of the website did not filter for valid input, which is more or less a name. So names usually just contain letters, very rarely numbers, but definitely I've never seen a name with a bracket or a smaller or bigger sign. We did it better. Here's the next iteration of the CERN phone book, and more recent. Still, you can still make some injection of HTML code. So this italic is, end of italic, underline bad, end of underline, and end of bold for everything. This is bad, I suppose, and it's reflected on the page, which is still a bit unfortunate. So one could have done more sanitization of the input here. So again, first message for you, and it will come back again and again, is keep your software such that you filter all input from untrusted sources. So for web pages, easy. Those are public web pages. I'm untrusted, so just don't trust me. And do this for everything else you're programming. So we get other problems. So hacking the Large Hadron Collider. Yeah, they defaced the CERN subdomain and have been one CPU away. No, they have not. But what they claim to have been able to do is something we call SQL injection. You see here HTTP : // and so on. At the very end, you see a standard SQL statement. It's more or less the hyphen or 1 = 1 -. So this is SQL injection. The whole command here after the equal sign is passed directly to the database and can do some havoc. So again, input validation and input verification is very, very important. Same thing here, directory transversal. You can even post some commands on the very top after the side equal sign, and with the dots and slashes, you just move up the folder tree on a Linux system, and then you execute /etc/password, and it gives you nicely displayed on the web page the password file. Once again, no input validation. Is another one without input validation, where you can even execute directly after the email equals. all the commands, and the last command, semicolon cat etc password, does the same thing, exposing the password file. Again, the question is, why do you accept the ampersand, percentages, and slashes as a command? So, and here's even one more, uname -a. What I will try now is, I would like to show you a video. This is a remake of an attack against CERN, a little bit older, but it's a very instructive attack where everything is happening in the URL bar, which I marked here with this red box. So it's starting there, and I will just explain to you just a little bit before, and what you should see is the attacker, and here it's redone by us for education purposes, but we call this from the logs we have from the attack, we are replaying exactly what happened. The attacker is playing around whether he can inject code. So is there some filtering of the input or not? And this is what's happening. So he's trying to inject code. He managed later to have this terminal, which is the grayish, the yellow grayish window in the middle, to pop up a window, a terminal, and then to execute directly from the terminal commands on this particular web server, to the point that he's able to compromise the system and take over the web server completely. So cross your fingers. I would love to show now this video, and let's give it a try. So I hope you can see this. If not, somebody unmics and unmutes and shouts at me. So here we go. You should look at the very top. You see the URL bar where the guy is trying to inject some standard easy stuff. So he's able to put LR123, and he's even able to put some arbitrary HTML code in. So this is already started with command line injection. And here's the real command line injection. And I'll stop you for a second. He's able to execute the command ID. Nothing critical there, but ID tells the attacker now under which scope the web server is running. And surprise, surprise, is running under the Apache scope. Apache is the user running the web server because this is an Apache web server. So no magic there, but this gives already some intelligence to the attacker. So the next thing he's trying is more severe. Uname -a. Uname -a, if you know about Linux systems, and you see the box on the left side, starting with the date of the 26th of November 2009, is telling you what is this web server. It has a name, it's running a Linux system, and you see the kernel number 2.6.9, and you see the uptime up since January 19, 2009. The attack happened in November 2009, which means the attacker now can just check on the internet what are the vulnerabilities, critical vulnerabilities, which have been published since January until now, November 2009, for this particular kernel. And there are zillions. This server has not been upgraded for at least 11 months, which means there are vulnerabilities in. And this is, apart from this command line injection on the top, is the second vulnerability, which I would like you to take home. Keep your systems up to date, because here it's not happening. And let's look at the video, see what the attacker is doing with this double information. So the first thing is, he is just easing his life, because it sucks a bit just fiddling around on the very top in the URL bar. So what he's doing instead, he is downloading something which he's calling a backdoor, a small software, which is now executed on the server, on the web server. So here you see the terminal from a colleague of mine, Romain Wartel. He's working for me, but he's now simulating the attacker, and the attacker is now waiting for a call from the web server. So here's the backdoor. Please hit enter. So there we are. Execute your BD, your backdoor, and call back to a machine called Alex Bra. And here you see the backdoor is now trying to connect back to the attacker. Here's the attacker, and bingo one. The attacker is now on the web server, but has a much more comfortable platform to interact. ID still on the web server, Apache, uname -a. Here's the web server, same thing you've seen before. Last step he has to do is he needs to have an exploit. And here's his exploit. He found this exploit. He's downloading this exploit from his sources. Takes a little bit of a couple of seconds, or takes a bit more seconds. Here we are. He's entering the file. It's called Wunderbar Emporium, which is a known exploit. And the last thing he has to do is execute the exploit. Here we go, /Wunderbar Emporium, shell, 3, 2, 1. Here he goes. This web server has been pawned, has been taken over. ID is not Apache anymore. ID is root, which means that within this 90 seconds video, the attacker managed to go directly from just the web access from the internet to this web server and taking over the server. just because there were two blunders not taken into account by the web server owners. One is keep your system up to date, and the second is make sure that any innocent unknown input is filtered. So if you're programming, you might not even go that far. You might already made the mistakes at the very, very beginning, because programming, the idea is you do not reinvent the wheel every time you do programming. So what about libraries? Who of you are pulling in libraries from third parties via NPM or PyPy or other tools? And maybe you do this even automatically into your code. Once there is a new version of whatever library you're pulling in, you just download it freely and without any verification. Hold on. Here is a small report from 2017 about a so-called typo spotting attack on NPM, where somebody detected some packages. And he was able to create the same package with a new version number, which is the more recent version number, automatically put in by you, but he added some malicious code. Here's another example. Here's another backdoor on a REST minus client, some library which you can download from GitHub, but it's containing a malicious door. And here's a third example, SSH decorator package. You can see even the code where there is additional software asking to, and start with the http://decorate.cf. It's extracting information from your computer. So if you're pulling in libraries, make sure that you pull in from libraries which you trust, from libraries which are on sources which you trust, maybe from peers you know, but just randomly copy pasting libraries from the internet has a, maybe small, but has a risk. And if you're doing programming, I know like you, sometimes you need to have secrets in your code to talk to a database, for example, or to do sudo, elevate your privileges, or for intercommunication between servers, some certificates, whatever else. Again, if you have those secrets in your code, think where your code might end up. So copy pasting, like in this example, your code on pastebin, and then you find it, and I just put it with black, it's private token, and you even say which project it is. This is blunder. Take care that your software is not exposing its secrets. Like here, the GitLab repository at CERN, you can find the certificates in the repository. And if I get your certificate, I can misuse this for connecting and doing havoc to your system. One more example, database connection at the very, very bottom lines, Oracle Connect. Username, there it is in plain text, and the password, again in plain text. This is something which must not happen. So that means, and on the very right side, tilted by 90 degrees, you can see a URL where you can learn how to use password alternatives in your code, so you do not have your password directly in the code. And if you have to, put this software, put the passwords configuration files, which you definitely protect in your repository separately, so they can never creep out, sneak out, and become public and being misused by the attacker. Having a look at password secrecy here, this is one of the control rooms in the LHC, one of the LHC experiments. Have a closer look. Do you see something wrong? I help you here. There's a small box saying passwords. So not too bad, but again, take care on your passwords. Here's another example in one of the accelerators. I was discussing with somebody about the Linux accelerators before, but this is in one of the Linux accelerators, a screenshot of a screen which is in a public place. A visit tour is going by, and if you look closer, the account is CERN. The password needs to be typed, and the password hint is, where are we? If I tell you that the password is a four-letter word, I think it's very, very easy to figure out what it is, and you just have to figure out now whether you take capital letters or small letters. And one more example, some university posted a very nice video on what they do at CERN on YouTube. Brilliant. And during the video, you see their whiteboard with lots of work they're doing, and they're very busy. If you look closer at the very top, you see a PCNTUA 05 test beam and the password. So this is how passwords going in, going out. Some people publishing their team viewer codes, and you even see it sometimes if you telnet it to the device, you see the default password. So think of your password, very, very important if you're a developer in your private life, but also if you're doing programming, worry about your password. Your password is the key to your digital assets. If you have your password to your computer at home, you are screwed, because what I will do, depending on my personal mood, when I get access administrator access to your computer at home. And this really depends on my mood. If I'm in a bad mood, which is rarely the case, I might just delete everything you got on your hard disk. Fine. Fuck you and gone you are, and you're lucky if you have a backup. I might be greedy, so I might not delete everything, but I encrypt everything. WannaCry is for Windows computers and malware, which was dominant in 2017. Everything on your laptop. And then I'll send you a nice email. I'll give you a screenshot and the background. Say, look here, pay me $300 in Bitcoin, and you get the decryption key. So if you pay me 300, I might ask for another 300 because it was just fun, wasn't it? Or maybe another 300 because really it's fun. Or I just give you the decryption key if I'm in a really good mood. If I feel lonely, maybe I just don't do anything of this one. I will just enable your webcam and your microphone and listen to what you're doing tonight. Watching which Netflix films you're looking for, whatever. So I'm just watching you the verse, maybe. No, it's not me. But anyhow, forget about this one. I might just go through your documents, waiting that you're doing internet banking, or you posting on Facebook. You type in more passwords, and once I get more password, I can just pretend being you and do Twitter feeds in your name and so on. So think of your password again. The password is your center of your life. So having a good password is definitely important. Multi-factor authentication is definitely better, but on the home computer, rarely I see people doing this. So think about this twice. Let's have a coffee break. Talking about passwords. Good, here we're coming back. This is a coffee machine at CERN. Nice one. You can have lots of flavors of coffee. You just type it on the touch screen. If you look closer, there's a small symbol called Frankie. If you hit on this one, you get the login screen. And nicely, the password was 7777 if you want to have administrator access on this coffee machine and getting your coffee for free. And you can even tune and tweak the pressure and temperature so you can have your perfect Italian cafe latte to your taste, because you just had access to the configuration of this coffee machine. Talking about Arduinos and Raspberry Pis and all these embedded devices, if you use them, you might use them a lot, oscilloscopes, systems on a chip, whatever else. Think of me, put a password, because the default passwords, like in this case, just Googling for Franke and the model number, which you can hardly see. It's on like C400 maybe. No, A800 is even on the screenshot here. You got the default PIN and the default operator password. So if you have embedded devices, the Internet of Things at home or on your project, change the default password now. At home, definitely, because if you don't, somebody who's able to Google it a little bit for the model you're running might take over your device. And if you take over your device, we might come back to what I said before: your private life is in danger. And if your private life is in danger, by the way, this even means that your project is in danger, which means that the CERN is in danger. And when the CERN is in danger, I have to do work protecting CERN. You see, it's just going back to you. And this is why my plea, just do a little bit more secure. This is what I'm running at home, my Internet of Things at home. Some of them I love, some of them I hate. I got a Sony television, which in principle I can connect to my Wi-Fi to watch films directly. I haven't done it because on the picture below, I'm using my Apple TV for that one. I got a Wii U so my son can play with his plea on the internet, so it's interconnected. My Yamaha sound system is interconnected because I would like to use Apple Air. I got a Sony Hi-Fi station, also on AirPlay, so there we are. Everything is interconnected. A solar power converter in the basement. Guess what? Interconnected, so I can see my power production per day and making tables and graphs and whatever else. And then, luckily, this is not me. I got a friend of mine who gave me this screenshot of his Nissan Leaf, and even he can connect remotely to his car to figure out where it is and what his configuration is, what the battery state is, and the next maintenance window is due. So everything is interconnected today, which makes cybersecurity more important. Keeping those devices up to date. Think of that one. This is already a pain. And for some of the devices, I will never able to do a new firmware in. And on others, it's just making sure that the default password has been changed. So here's the world's first IoT screw up in 2018, where somebody managed to install some malware on millions of small little routers in homes and use this to attack via DDoS, a distributed denial of service attack, against different web pages. He's even selling this to third parties, making money. So if you don't like the CERN, you pay this guy behind this Mirai botnet to attack the CERN, and all those million devices will start making queries against CERN, and this will definitely bring our firewall down. That's a normal case, just a question of who has the bigger pipe. And if you're talking about millions of devices producing terabytes or teraflops, terabits per second, attacking CERN, we might have a problem. And indeed, yes, we might. So going further now, coming to the rescue. This is why I'm here. My plea to you: let's go and look why you are important. Here's a very old picture about the relative cost of fixing software defects, bugs, vulnerabilities, whatever else. If you get it fixed during the requirements definition phase, design phase, or programming phase, the costs are quite acceptable. Takes you a little bit more time, admittedly, maybe a little bit more training. Maybe you cannot rush as quick as you want to, and this is the Webfest. Developer testing already costs more. Customer testing, when you roll this project to CERN or somewhere else, I have to do the testing, and I don't have all the background on all the things, and you have definitely not documented everything in the nitty-gritty details. The costs are even higher. And once it's deployed, then we're really screwed up. Then applying security patches, correcting your bugs can become very, very expensive. So what might you work on, or what I am working on actually? That's my role. I'm trying to fix the problems. I'm not pointing to you, but let's take you as everyone else created, when everyone else tried to fix the problems everyone else created, when they try to fix the problems they created. So it's really, we're trying to fix the problems again and again and again, instead of getting everything well done at the beginning. So here is a webpage. I definitely recommend you to help us. It's a webpage of security scanning tools, static code analysis tools, which you can run on top of, in this case, C, C++. All of them but one are free, so you can download them from the internet. Just click on the names and you get the URL. I hope they're all up to date. There's one which is to be paid, Coverity Prevent. It's quite expensive, but it's a brilliant tool. And this is definitely something for you to run over your software to make sure that you don't have any obvious security blunders. And this is not only for me, but it's also for you, because you don't want that your software is crashing every hour, every day, every week, or maybe even just every 10 years, because you have somewhere a memory leak which you didn't protect properly for, and then it's eating more and more memory up, and once it's eaten all the memory up, the computer is going on its knees. We get similar tools for Java, if you're a Java fan. Perl, I still like Perl, but I got already that nobody likes Perl. So here's Python. You might more like Python. So there are lots of tools. Just download them. PHP if you're doing web programming. And if you're at CERN and you got your project at GitLab, at CERN's GitLab, we got even Docker images, which you can integrate into your integration framework to run on each new build. So it's even automatically. And this is the next thing. If you're using a compiler, give the compiler a chance. There are lots of people working on the compilers, making the compilers brilliant. So there's the warning option, -w all, which is really interesting. Use it and do not ignore the errors and the warnings. They might be nasty, there might be many, but take it as your personal pride and make sure that you don't have any, because in that case, we can be sure that there is nothing which is compromisable, nothing which is vulnerable in your code, at least nothing known which is vulnerable. And if you want to go on the webpage, there's this very nice tool, Software Assurance Marketplace. The URL is mir-swamp.org. You can upload your software, please, without your credentials, certificates, and passwords, but your public software, you can upload it there and get it analyzed online. This is the easiest way for you, and in particular, if you're students, it is your interest to publish your code. So put your code on GitLab, on GitHub, on wherever else. Make your code public and reference your code from your CV, because this is what I'm looking in when I'm hiring. So here's a new developer. Oh yeah, he was doing some Java code. Let's look at his code. Is it well documented and so on? So it's in your interest. Publish your code, so can you also push it into Swamp. I think Swamp has even hooks with GitLab, and then you can get your code checked. If you're having a web page, being at CERN again, at Apex website, we got even built-in vulnerability scanners which you can run on top of your website. So this is for web developers. The same for random web pages. Here on the right-hand side, you can see the CERN web service. The web page is called CERN APEG. And a little bit down, you can demand a security scan, where we are just running a security scan on top of your web page and seeing the security stance of your web page is. If you're not working at CERN, fine, fair enough. We cannot have everybody working for us, which is a little pity, but such is life. Download this tool called OpenVAS. This is an open vulnerability assessment system, not dedicated for web pages, but also for servers. You can run it against your server. Make sure that you get the right to run it against your server, because OpenVAS can be very, very nasty and very consuming. So if you want to run this on a production system, really make sure that the production system at the moment can be tested, or you might bring it down. If you want to have fun, run OpenVAS against the Internet of Things. Do it at home, run it against your television. Might be fun. Might render your television also dead, so it cannot boot anymore. That would, of course, be a little bit unfortunate. But you see, those are the possibilities which are there. OpenVAS is a brilliant tool to be used. Against web pages, you can use Skipfish. It's a web application scanner made by Google. This is what we're using before we approve web servers to be visible to the internet. We do an OpenVAS scan, and this must be a scan which turns out to be super green. And the same for Skipfish. Super green is the only color we accept. If there's anything which is fishy, yellow, or red, too bad. So if you're working for a project at CERN, which is supposed to be developed and deployed at CERN, listen to me once more. Maybe even get in touch with us quick enough, because if you have now setting up a nice web server, you have to pass me and my team. If your web server is not secure enough, if it's not super green, no opening, and I bet you your supervisor will be really pissed off. I had that in the past. And if you want to do more, OWASP, the Open Web Application Security Project, lots of learning, lots of reading there. You can learn more about how to improve the security stance of your web page and of other things. We're giving training, might only apply for the people who have access to CERN and developing secure software or Python coding or Java coding. We're training white hats. So if you are at CERN also in September, let us know. Or if you're living in the vicinity, just contact us. We're training CERN people to become hackers, to do vulnerability assessments, to penetrate into systems, and just to learn how this is done technically. That would be another talk, but this is very, very interesting to learn how you can break into web servers in particular. Like I've shown you on the video, there are many, many different ways to do this, and we're training our people to use it against their systems to improve the security stance. Here you can see an example, competition more or less. We set up a web page, a fake web page of a fake video film distribution database. You can see on the left-hand side behind the black box all the participants, and then you get exercises. So some have done 6 exercises, some have done only 5 exercises, and with green color showing that they succeed in the exercises. So it's starting a little bit with easy exercise, and then it's getting more complicated. It's called Capture the Flag. This is something for beginners. There are even tournaments on Capture the Flag where you can go, but you need to be a little bit more focused on security. But you can try yourself. CERN one is only for CERN people, but hack yourself. There's the Google Gruyere project. The URL is on the bottom left, where you can test your hacking skills, your penetration testing skills on this particular application. There's the Damn Vulnerable Web Application, the DVWA, where you can try to hack into and show your skills. Hackthisite.org gives you other means to test your skills in penetration testing. And then, of course, OWASP, I mentioned already, the Hack Code project and the Academic Challenges project. Those 2 projects can be used again to learn how to do penetration testing yourself. And I gather most of you are young students, not in old iron like I am, so your brains are still fresh and massageable, and you can learn. So if you want to really advance in the world of IT, those are definitely courses which are highly asked for. And if I see somebody having done Google Gruyere or OWASP Web Code, this is definitely something really appreciated. So this is a booster for your CV. So here's my plea to you, my last slide to wrap up. I said it before, I'll say it once more. Check your input when you're getting input from unsolicited third parties you cannot trust, and test it on your web server side, on the side which you control. So if you have a website, do not make the control of the browser of the user, because you can still manipulate the data afterwards. Test it on your side. Discard anything what you don't expect. If you're expecting names, accept names. If it's a date, there shouldn't be letters in, and so on. If it's number between 1 and 100, negative numbers should not be accepted, and so on. Think about your password. Your password is key. Your password gives me access to your computer, to your system, to your project, to your data, to your mailbox, to your private life, and to your professional life. So protect your secrets in work and university. on your computer at home. If you have accounts with Instagram, Facebook, wherever else, check out whether they get multi-factor authentication, and definitely now's the time to enable multi-factor authentication. It's a little bit more difficult, more complicated, because you have to start up your smartphone and getting the second factor, but that is the ultimate level for protection against password theft. Do not reinvent the wheel. Check with your IT guys wherever you're working. Check with your project managers. For the people working at CERN, you don't need to set up a database. We got a database service, which you just can ask for. You don't need to set up a web server. CERN has a web service where you can get a web server from, and so on. So for everybody else, check first when you're working in a team. Maybe somebody has already web server running. Maybe somebody has web server expertise or database expertise. Tap into the knowledge, learn from them, but don't reinvent the wheel. There's lots of other things to be reinvented, so don't do things others have already done. Last but not least, don't make mistakes twice. Read a little bit about cybersecurity. It's stupid doing the same mistakes again and again and again. I've shown you cross-site scripting now. This has been done. People have done cross-site scripting mistakes. So learn from them, check every input, and I'll set it again. But again, learn from those vulnerabilities. This is what this talk is for. I showed you some areas where you really can screw up. Just don't do those mistakes. There are plenty of other mistakes you can do, but at least learn from those ones. It's like touching a hot plate. You just do it once. If you do this twice, honestly, I would think about your insanity level. Here again, my tools for programmers. You can get to this public webpage. There's my security checklist. There's how you keep secrets secret, and how you do static code analysis tool. There's also a link to our GitHub static code analysis framework. And here again, OWASP tool, Hackademic, and there's Google Gruyere, and so on. So if you get questions, not only in emergencies, but also outside, computer.secure.cern.ch. If you're working with CERN, for CERN, or doing something with us, just drop us an email. We are there, not 24/7, but usually we're trying to. So if you're a little late in replying, fair enough. It's not urgent enough for us to just move out of step out of the cinema, or just stop the Netflix film, but usually we're quite intact. So, and with this, I think I accept questions first, and we can see if we get some time left. So, here I am. Questions. Wow. Did somebody listen to me? Cool.
If you have any questions, please unmute and post the questions to Stefan.
Crystal clear or completely opaque?
I wanted to know, because I think for many of our projects, we might use some already done frameworks like Flask or Django or things like that. And what is your point of view about the security of such frameworks?
This is a very broad question, so we really have to look into each of the single frameworks. So I'm not in the position to really compare which one is the best one, because you can't even choose. So if you got a dedicated project, you can drop us an email. We can have a look into this one. But again, if your framework is the most recent implementation of the framework, at least everything what is known in vulnerabilities should have been fixed by then. So just make sure that you do not run an ancient framework. If you do, check on the web page. So check on the corresponding web pages whether there are more recent versions, and if they are, maybe discuss with your supervisor and see whether you can migrate to a more up-to-date version.
Okay, perfect. Thanks a lot.
Any other questions?
Just there, I'm a nice guy on Saturdays between 12 and 1.
Well, I think so far there aren't any further questions. So from our side, again, Stefan, thank you very much for this great talk, which was informative and entertaining alike.
Welcome.
It's an honor to have you here. And also to all our participants, thanks for joining. And yeah, happy hacking to everyone.
Happy friendly hacking, please. If you find something which is vulnerable, let us know. Computer.security. We are really aiming for fixing everything.
Okay. Thank you very much. Bye.
Thank you very much. Cheers.